No, I don't want you to die. Okay, here we go.
He just wants us to
A person is running an elliptical track, on an elliptical track backwards, and I added the word clockwise, so you guys know what backwards is. The equation of the track is this. Oh, that's kind of interesting. And then there's a track right here. Look, there's a cute little picture. I think I stole this out of the book, guys. So here's this runner, this elliptical track. Okay, I don't even think tracks are really elliptical like that. They're more like box shaped, but still round. Anyways, when the person is at the point 5,2, her x-coordinate is increasing at 6 units per minute. Do you guys see that? Minutes? That's a time thing, right? Time. Okay. Describe how her y-coordinate is changing. So we're talking about time here. So that would be like a related rates question. We're going to take the derivative of this with respect to time. Now let me oversimplify this. Let's see. We know that x equals 5, and we know that y equals 2. Right? We know that the change in x, which with respect to time, because it told us in time, is 6 units per minute. Right? So what's the question? The question says, what is dy over dt? So we have to have an equation that we can take the derivative of with respect to time so that we have a dy over dt. Which is given to us. Oh, I covered it up. What is it? Is it 25x plus...
No, it's
4x squared plus 25y squared? Equals 200. Okay, this is what a lot of people forget. I'll tell you guys what people forget. Let's see. First, we got to take the derivative with respect to t. All right, first thing we got, drop the 2, multiply to the 4, so we have 8x. Some people forget the x prime. Okay, now I'm going to write dx over dt. You can write x prime if you want. That's fine with me. And then on the next one, I drop the 2, I get 50y, and then I have dy over dt, which is the same as y prime. And this is what people forget. What's the derivative of 200?
0.
Oh, yeah. It's so simple, right? But it's so easy to forget, too. Now, when we look at what our result is, we have 1, 2, 3, 4 variables in this equation thing that we have. Do we have all of those? This is the prize. That's what we want. We want dy over dt. We have an x, which is 5. We have a dx over dt, which is 6. 50. We have a y. What's our y? It's 2. And then dy over dt is what we're looking for. All right, so we got now only have one variable. 8 times 5 is 40 times 6 is going to be 240. Let's put them on the other side. We have negative 240. So I just multiplied this. I got 240 and put them on the other side. And on this I have 100 times dy over dt. So what is dy over dt equal? Dy over dt equals, what is that? Negative 240 divided by 100, which is going to equal negative 2.4. Oh, but wait. What are my units? Units per minute. If you left it as a fraction, I mean, you could probably even leave it like this, but I just can't do that. I don't like that. What do you get, like 24 over 10, or you can write 12 over 5. All these answers would be good. I would simplify just because I hate leaving it, but some teachers say don't ever simplify. Because if you mess up on your simplification, you lose a point. That would suck. Okay, so hey, next question. Can she run in such a way that her x-coordinate changes at a constant rate? Can she run so that dx over dt is constant? Now, for the sake of time, I'm not going to write it. I'm just going to explain it. You could say, no, she cannot run in such a way that her x-coordinate changes at a constant rate.
Oh, why? Because
if she is running at a constant rate, the x-coordinates would actually change at a different rate. Think about this. If your track goes like this, and your person is running right here at a constant rate this way, the vertical change is this horizontal line going back and forth. Look at that, back and forth. One way is going to be a positive rate of change. The other way is going to be a negative rate of change. That's one thing you can say. It can't happen because pretty soon they're going to get right here, and then their x rate of change is going to be going negative. It's going to be going the opposite way. Or you can say during the turn, actually right here, even though my runner is running at the same rate, they are now like going up and down. They're not going left and right. So their rate of change, the x rate of change, is actually going to be 0 at a certain point. Right? Okay. So that was the answer, no. You can't do it. Okay, but what if and you have to write that in words, but try to simplify it. Now what if I said yes? Yes, the runner can do it, absolutely. On the straightaways, that runner needs to run very, very slow. But then when that runner gets to the turn, that runner needs to slowly increase their speed and they need to be running the fastest when they get to this point, and then start slowing down and run really slow right here. That would keep the x-coordinate at a constant rate of change. So I would take both answers. This is kind of a weird question. I don't think this would actually, well, it could be. Never mind. It's a weird question. But that's it for that one. Let's go to this last one. Oh, this was my favorite part. I think this part is worth 4 points. Okay. So it says the inside of the track is heavily wooded and she cannot see through the woods. Oh, okay. There is a bear standing. Oh my goodness! Outside the woods at this point, 8-0. Oh my goodness. When she is at the point 5-2, which is right there, can she see the bear? Your line of sight is a straight line, right? Wouldn't it be cool if you could actually bend the light and see around a corner? Oh man, you would be immortal. All right, you just wouldn't be of this realm, right? Okay, so our question is the tangent line that we can draw right here, going through the runner to the bear. Can she see the bear?
Yeah.
Well, it really depends, right? It depends on where this tangent line crosses the x-axis. I need to know where the tangent line crosses the x-axis. So there's two things I need. I need a tangent line, and I need the x-intercept of that tangent line. And then I would know. Now I'm just talking it out with you guys so you can understand what's going on. What if my x-intercept was 12-0 of this tangent line? Would she see the bear? No, because 12-0 is like way over here. She'd be passing. She wouldn't be able to see the bear. But what if the x-intercept was like a 7-0? Would she be able to see the bear? Well, that means she would be able to see right here, like right in front of the bear, right? So then wouldn't she see the bear? Because there wouldn't be woods there anymore, right? No woods. She can see 7-0, then she can see 8-0. Here, let me redraw the line of sight. Maybe that'll help. So if she can see, if she can see way over here, then yeah, she would be able to see that bear. But if she can see, if she can only see way over here, then the woods would be blocking the bear right here. You wouldn't be able to see the bear. If the tangent line crosses right in front of the bear, then yeah, she'd be able to see the bear because she could just look out this way and see it. She can't look this way into the woods and see the bear. She has to look out, this way. I don't know. If you don't understand that, then you gotta come talk to me. Okay, so how am I gonna find my slope? Now this is where it gets weird. I need a slope for this tangent line, and we're talking about x and y. Are we talking about time? We're not talking about time. Oh my goodness. So we're not doing like a related rates thing where we're implicitly deriving with respect to t. Instead, we're going to take the derivative with respect to x because we want to see how the y changes over x. What? Yeah, it's regular implicit differentiation. So we got, 4x squared plus 25y squared equals, what did it equal? 200. All right, so we're going to take the derivative of this with respect to x because I need a regular slope. All right, so I'm trying to get a y prime. And just because I know you guys like it, let's use y prime instead of dy over dx. Or? No, okay, I'm going to stick with dy over dx. Okay, so take the derivative of this. It's going to be 8x. And I don't have to multiply it by dx over dx. Dx over dx is 1 anyways. That's weird. Okay, so then we have 50y, and then we have dy over dx. Or you can write y prime. You can do it. Equals 0. All right, so what's my slope? My slope is dy over dx. Ooh, that means I just have to get that alone. Now, do I have an x and a y coordinate? Oh, yes, I do. Is it the 8, 0 or is it the 5, 2? It's the 5, 2. We want a tangent line at the runner, so we're going to plug in a 5, 2. We have 8 times 5, and then we have 50 times 2. Now we're trying to get the dy over dx alone, so let's do that. I'm going to move that 40 over here, so it's going to be negative 40. And then we have 100 times dy over dx. I got that 40 from the 8 times 5, by the way. And then I divide both sides by 100, so I get dy over dx equals negative 40 divided by 100, which is just 4 divided by 10, which is just 2 divided by 5, negative. Okay, I shouldn't box that. That's not my answer. That's my slope. That's my slope, people. Now, in order to write a tangent line, I just need a slope and a point. So we have y minus 2 equals my slope times x minus 5. And then I gotta simplify this. So let's see, I get negative 2, 5x, and positive 2. Yay! I love that. When we have a fraction multiplying to its denominator, the denominator goes away. Okay, and then we have y minus 2. We're going to add 2 to both sides, so add 2 over here. My tangent line is negative 2 over 5x plus 4. Now, what was the other thing I need to know? Once I got my tangent line, what was the other thing I needed to know? I need to know the x-intercept. And so how do I find the x-intercept of a line? You plug 0 into the y and then solve. So I have negative 2 over 5, x plus 4. Subtract 4 from both sides, so I have negative 4 equals negative 2 over 5x. Multiply both sides by negative 1. Multiply both sides by 5 to get rid of this fraction thingy guy right here. And then I got 2x. X equals 10. My x-intercept is 10. Can the runner see the bear? No. Because the closest, because her line of sight can only see x or anything greater than or equal to 10. I like that.